In this video here, we're going to be reviewing for the Chapter 1B test. We're going to start off with using graphing or substitution or elimination to solve some systems of equation. And these are 2x2 systems of equations where you have x and y. Now I want us to notice like some of these questions are in standard form where the x's and y's are lined up. So as you can see, number 2, 3, and 4 are all in standard form, where x's and y's are all on like the left side and then the constant on the other side. Whereas number 1 here has the just regular slope and intercept form where you have y equals mx plus b, so in that format. When you have it in this format, the best way to solve it is either by graphing or substitution. So if I were to graph this here, what I'm going to start to notice is the slopes are both the same. And one of the things we mentioned is if the slope here is the same, so this slope here is a 2, and this slope here is also a 2, anytime you have the same slope, we know that the lines are parallel. Well, if we kind of draw two parallel lines, right? Two parallel lines are always going to be running along each other. They're never going to intersect. So if they don't intersect, that means that there is no solution. So for this one here, we don't really have to solve it out because one of the things I want you guys to notice is that if the equation has the slopes are the same, then this is going to be parallel lines, and parallel lines never have solutions because there's no intersection. So in this case, this is no solution. Let's try number 2 here. So number 2 is set up in standard form, so x and y's line up nicely. So I'm going to use elimination to solve since it's already in that format, and elimination is a little bit easier to use for standard form. If I look at the two equations, I need to decide what I want to cancel, and maybe let's go with the y's, because I noticed that this y here is a positive and this one's a negative, so maybe I'll make this bottom here a 2, a negative 2 if I multiply the bottom by a 2. So if I use elimination, I'm going to drag down the first equation since I did nothing to it. So x plus 2y equals negative 1. And then I'm going to distribute the 2 into the equation. So this would be 4x minus 2y equals 26. 3 times 13 is 26. From here, I'm going to combine the like terms. So if I combine the x's, 1x with 4x add to be 5x. And the two y's cancel because they're opposite signs, so I can get rid of that part. Negative 1 plus 26 gives me 25. If I want to try to get this x by itself, I need to divide by 5. So it looks like my x here is 25 divided by 5, which is 5. So I found my x. I need to get my y value. So I'm just going to plug it into one of the equations. I'll just choose the top equation. It doesn't matter. So if I plug it into the first equation, I have 5 plus 2y. I don't know what my y is. So I've gone ahead and plugged it in and wrote it out here. And I'm just going to work it out. So I have 5 plus 2y equals negative 1. Maybe I'll move the 5 over by subtracting. So that would cancel. So 2y comes down. Negative 1 minus 5 gives me negative 6. If I try to divide by 2, the 2's cancel and y comes down. Negative 6 divided by 2 gives me negative 3. So from here, I can write my coordinate as my x, which is 5, and my y, and that's negative 3. So this is my x value, and this is my y value that I get. And that is my final answer. So make sure you write it as a coordinate so that way you know that this is going to be one set of solutions. So when we write it as a coordinate, we can see this is just one solution because that tells us our intersection, and there's only one intersection. All right, let's try out 3 here. So for 3, we have two equation and the x's and y's line up, so we're going to use elimination. Might be best to use that. If we were to use elimination, I'm thinking, well, maybe I will try to get rid of the x's. I can make this x a negative 3 to try to cancel out with the positive 3 on top. So I would distribute a negative 3 in. Now let's carry down the top equation first since I'm not going to do anything to it. So I'd have 3x plus 6y equals negative 9. If I distribute the negative 3, I have negative 3x minus 6y equals positive 9. Negative 3 times negative 3 is positive 9. If I combine these equations, I notice something interesting. Looks like the x's cancel and the y's cancel. So I'm just left with 0 on the left-hand side, but also negative 9 and positive 9 cancel to give me 0 as well. We've learned that anytime you have 0 equals 0 and everything cancel and you just end up 0 equals 0, since both sides do equal each other, this is what we call infinitely many solutions or infinite solutions. So anytime you notice like your variables and your numbers cancel out, that means you have infinitely many solutions if you get both sides to equal each other. Also, just a reminder, anytime it's infinitely many solutions, that means your two equations or your two lines here actually end up being the same lines or the same equations. So a little note there, but this is infinitely many solutions. Because apparently if you were to graph this, you would have graphed the first line and you would have realized the second line is just the exact same line. So when the two lines are on top of each other, that means they intersect everywhere. And so that's how there are infinitely many solutions. All right, so going into number 4 here, it's also in standard form. So let's go ahead and use elimination. Now for this one here, I have to be a little strategic. Maybe I want to cancel out, let's go for the y's because I already noticed they're opposite signs. So that's a 5, that's a 4. 5 and 4 can both be 20 if I multiply the top by 4 and I multiply the bottom by 5. So my goal is to make both the coefficients for y's 20, and they're already opposites in sign, so I don't have to distribute a sign. So I'm going to go ahead and distribute the 4 in for the top. That would give me 16x plus 20y equals 4 times negative 12 is negative 48. And then I'm going to distribute the 5 into the second equation. So that's 15x minus 20y equals 5 times 22 gives me 110. So from here, I'm going to go ahead and combine the equations. Like I said, my y's cancel. From here, I can see that 16 plus 15 gives me 31. I'll bring down the x. Negative 48 plus 100. Let's see what that would be. So I'm grabbing my calculator here. So if I take 100, subtract 48 from it, I would have 62. So if I divide by 31, the 31s would cancel. X would be equal to 62 divided by 31 is 2. So I have my x. I need to grab y. So I'm going to plug it in maybe to the first equation. Or let's try the second equation. Let's be a little different this time. Like I said, it doesn't matter. So if I choose the second equation, I have 3 times 2 minus 4y equals 22. So I'm plugging this 2 in for x, and that's why I have 3 times 2, and I'm solving for y. So this would be 6 minus 4y equals 22. I'm going to subtract over the 6, and this would be negative 4y equals 22 minus 6 gives me 16. So if I divide by negative 4 to cancel out that negative 4, I have to divide it to the other side, and y is equal to 16 divided by negative 4, which is negative 4. So I have my x, I have my y. We're ready to write this as a coordinate. So that's 2 and negative 4 because that is my x, that is my y, and because we have one set of coordinate or one set of intersection, we have one solution. So I like to label how many solutions I have. Oops, sorry. I like to label how many solutions I have because it helps me identify what type of system of equations do I have. Remember, there are three types. There is no solution, infinitely many solution, and one solution. Those are our three types of solution for systems of equations. All right, let's get into our story problem here. We have one about a youth group that is going on a trip to an amusement park. So they're traveling on two vans, and the number of people in each van and the total cost of the admission are shown in this table. It's kind of cute. It's like a table shaped like a van. Find the adult price and the price of the student's admission. So we're trying to figure out the price for adults and the price for students. So let's write that down and declare our variables. I always start with, when I'm solving a systems of equation, to declare my variables. And in this case, I'm looking for the adult price and the student price. So from here, I can try to look at my table and figure out what I know to make two equations. So let's try to make two equations from this. The first thing I know is, like, if in the first van, van A, 2 adults were in the van and 5 students, and the total cost for their admission was $77. Well, if that's the case, then if there are 2 adults, I can multiply that by the price of the adult tickets, which I don't know what is the value, but I'm calling it X. So I can multiply the number of adults by the price of the ticket, so that's 2 times X. And then I can do that for students, so I can do 5 times Y, the price of student tickets. And I can add them together to get me $77. And I would also do this for the second van, van B. So I would take the 2 adults that went on, multiply that by the adult price, so 2 times X, plus 7 times my Y, which is the price for students. And that should equal or total to be $95. Now, once we have done this, we can go ahead and try to use elimination to solve for it, since it is in standard form. So maybe I will try to cancel out the x's since they're already both 2's. And I will try to distribute a -2 for the top. It doesn't matter. But if I distribute a negative, sorry, not a -2, a -1. If I distribute a -1, I'm able to flip all the signs to be negative. And I really want this guy to be a -2 so I can cancel out with the bottom 2x. So if I take the top here and distribute the -1, that would get me -2x minus 5y equals minus 77. And then for the bottom, I did nothing to it, so I'm just going to bring down the second equation. So I just brought this equation down. And now I'm going to combine the like terms. So the x's cancel because they're opposite signs and the same coefficient. -5 and 7 add to be 2y. And -77 plus 95 is going to give me 18. Oops, there we go, 18. So if I divide by divide by 2, if I divide by +2, my y is equal to 18 divided by 2, which is 9. So it looks like my y is 9, and the y is the student prices. It looks like the student tickets cost about $9. Let's go ahead and try to figure out what are the adults' prices by plugging 9 in for y. So I'm just going to choose maybe the first equation to plug it in. So the first equation is 2x. I don't know what x is. But my y here is 9, so I'm going to plug that in. If I work this out, 5 times 9 gives me 45. I need to try to get this x by itself, so I need to move over the 45 first. And so I have 2x equals 77 minus 45 is 77 minus 45 is 32. If I divide by 2, x is going to give me looks like 16. So I found my two variables. Let's go back and label this. So it looks like the adult price is $16, whereas the student price is $9. And so that there would be my solution. So I found the price for my tickets. And that's it. So when you're dealing with a story problem for a system of equation, it's really important that you declare your variables. From there, you need to write your two equations using the information that you're given. And then you want to use elimination to find each variable. And lastly, make sure you write it in your answer in the context of the story. All right, let's do number 6 here as our next story problem. So in this one here, it talks about Principal Jackson. He spent $888 for 30 trees and shrubs to be planted at Norman High. If he pays $60 per tree and $12 per shrub, how many of each did he buy? So first off, let's figure out what we're trying to solve for. We're trying to figure out how many of each did he buy. That's talking about how many trees and how many shrubs he bought. So my X could be number of trees, and my Y can be number of shrubs. So from there, I'm going to make my two equations. My first equation, if I think about it, well, I know that the total amount of trees and shrubs I got that Jackson got was 30. That means if I were to add up the number of trees I had, so X, and the number of shrubs, which is Y, so if I add up X plus Y, I should get 30 plants. So from there, I can also use the price tag to help me out. So I know that he spent $800. So I know that if I add two things, I would get $888. So this tells me, well, I know that each tree is $60. So if I take $60 and multiply it by the number of trees, or 60 times X, I would get the total cost that I spent on the trees. If I take $12 for each shrub and multiply it by Y, I would get the total amount that was spent for each shrub, or all the shrub together. So from here, I have my system of equation and I'm ready to use elimination. If I were to use elimination here, I need to cancel out one of the variable. It might be easier to cancel out the Y since the numbers are smaller. So this here is a 12. I'm going to make this a negative 12 by multiplying with a negative 12 into the top equation. So that means my top equation is going to be negative 12x minus 12y equals, let's see, what's negative 12 times 30 is negative 360. And then I'm just going to bring down the second equation as it is because I don't need to multiply anything to the bottom equation. So I just brought it down. I'm ready to combine my terms. Like I said before, the y's cancel, which is nice. Negative 12 plus 60. If I take negative 12 and take 60 minus 12, that's going to give me 48x. And then I have 888. And I need to add 360 to it. So that would give me 528. If I divide by 48 here, that would cancel. And x is equal to 528 divided by 48. Let's see if that divides nicely. So when I divide, I actually get 11. So if I know that x is 11, x is the number of trees, I can find the number of shrubs by just plugging it into the first equation, or just taking it away from 30. Since there's just 30 plants, if you subtract 11 from 30, you can get the number of shrubs you have. Or you can just use the equation. So I have 11 plus y equals 30. All I did was plug my x into this x, and I'm going to work this part out by subtracting 11 to both sides. And y is equal to 30 minus 11, which is 19. So that tells me that there are 11 trees and 19 shrubs. So Mr. David Jackson seemed to have bought 11 trees and 19 shrubs. And there we go. And again, I had to declare my variables first, make two equations using the information that was given, use elimination to solve for my variables, and then write my answer in context of the story problems. All right, so I'm going to pause the video here. If you want to see how to do the rest of the review, watch the next video.